welcome to chemistry, another action-packed day today. Today we'll be doing the factor label practice test. Oh, that sounds so fun. All right, let's just get started on this thing. All right, here's what we have. It says we have 15 grams of magnesium sulfate, and we're turning that to moles. Set up 15 grams, and we're converting that to moles. MgSO4. Set up like that, nice and easy. Now we have to cross out those grams. So we're going to put grams down here. And that crosses out our grams for us. Now we have moles over grams or grams over moles. That moles is always going to be a 1. And that mass is going to be the total from the periodic table. So let's get a calculator action going here. We have Mg, which is 24. Plus we have sulfur, which is 32. Plus we have oxygen, which is 16. And we have 4 of those, so times 4. So on my calculator, I have, well, it looks backwards in yours probably, 24 plus 32 plus 16 times 4. Press enter, and I get 120. 120 grams of magnesium sulfate per 1 mole. That's our equivalent. Into the calculator, we take 15 divided by 120. Answer, 0.125 moles. You're like, Mr. Arnold, I can't see that because your head's in the way. Well, we'll fix that in just a second. Doo-doop. And there's your answer. Okay? So, simple as that. That's the first kind of problem there's going to be. That's a gram to mole. I'm just going to sit right up here this time. All right, moving right up. This time we're going to change moles into grams. So this is the opposite way of that. When I say opposite way of that, that's just chemistry opposite for us. So we have 4.23 moles of calcium hydroxide. And we're going to change that to grams of calcium hydroxide. Cross out the moles. If you have grams over moles or moles over grams, the moles is 1. And the grams comes from the mass in that periodic table, so it's calculator time again. So we have calcium, and calcium is 40. Plus oxygen is 16, and there's 2 of them. 16 times 2. Plus hydrogen is 1, and there's 2 of them. So I'm just going to say plus 2. Oops. That didn't turn out the way I wanted on my calculator. 2 plus 2. And enter. I got 74. 74 grams. All right. This time we're going to multiply. So 74 times 4.23 equals, I'm getting 313.02 grams of CaO. Whoa! What happened there? Hey, I'm back. I'm not sure what happened, but let's get that off of there. Of CaOH2. Right? To our next problem. This time we have moles. Convert the number of moles. Just because it's in scientific notation doesn't mean that it's the number of molecules that says moles to the number of molecules. All right. So this time we're going to go from moles. 6.22 times 10 to the 5th moles. And this is going to be molecules. I'm just going to put a number sign. It's the number sign, right? And then on the bottom, we're going to have moles, right? So if you have moles, in this case, moles are going to be 1. Moles are going to be 1 right now for this whole entire chapter. If you ever have a number in there that's not 1 for moles, then I'm not sure what you're doing. All right, and the number is going to be 6.02 times 10 to the 23rd. All right, so we have that many moles. And we don't have to look anything up. There's no mass this time, right? So we just do it right through, 6.22. And then you're going to push that second comma if you have this one, which is the E button. And then to the fifth, and then times 6.02, second comma E, 23, boom. And I get and I get 3.74 times 10 to the 29th. And that is actually the number of molecules. Right? Molecules and moles are not the same thing, people. Don't get them mixed up. Going on to the next one, we have molecules to moles. This time the number, we're going from the number to moles. All right, we'll start off with that number that they have. They have 1.67 times 10 to the 16th. On the bottom, 6.02 times 10 to the 23rd, 1 mole. Remember, moles is going to be 1 in this whole entire chapter. If you're getting something different, then you are doing something wrong. Oh, calculator got the best of me there. I don't know what happened. Window, trace, zoom, graph, nope. Mode, nope. Delete, nope. Y, I don't know what's going on here. All right. Switching over to the iPhone calculator because I just messed that one up. I don't know what I did. Okay, so now we're going to have all right, so we have 1.67 E button, and then 16, then push divide. Maybe I have to push equals in this, I can't remember. I'll do that. Divide by 6.02 second, or just EE 23 equals, and then I'm getting this decimal. I can count it for you. I'll write it out. Either one is correct. There's 1, 2, 3, 4, 5, 6, 7, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros. 277, which would be the same as 1, 2, 3, 4, 5, 6, 7, 8 places. 2.77 times 10 to the negative 8 moles. And my face is in your way again, and this is what it looks like. Okay, same number, means the same exact thing. All right. I got too many computer screens going here, don't we? All right, so this time we have grams, and we're going to go from grams to the number. This is the big one. This is the big one, kids. Here we go. So we're going to go from the grams, and it's 14.31 grams. Let me move that grams over because I put it in the wrong spot. Grams of Na2S. And we're going to moles. You have to go to moles if you're trying to change in grams into anything. You have to use moles. Moles is the middleman. You have to be in the middle. And then we're going to go to the number. All right? So this is grams to moles to the number. We're going to cross out grams. We're going to cross out moles. If you have grams over moles or moles over grams, the moles is 1. In this case, we see all the moles are 1 in this chapter. Put 1s in. Now we have to find the mass of that grams. Na is 23. There's 2 of them. Times 2 plus S is 32. So plus 32 equals 78. So sodium sulfide is 78 grams per 1 mole. The number is Avogadro's number, 6.02 times 10 to the 23rd. We put that up top. And now we have us a little calculator fun. So we're going to have 14.31 divided by 78. Anything on the bottom, make sure you push divide first. Times 6.02. Turn your calculator sideways. E 23 equals, I'm getting 1.104 times 10 to the 23rd, and that would be Na2S molecules. Again, not something very practical to figure out, but what the heck. All right, now our last one we're going to do is we're going to go from molecules, so we're going from the number to grams. So we're going from the number to moles to grams. Crossing out my things, I need the number on the bottom, I need moles on the bottom. Hey, we already said this. If you have moles, it's going to be 1 in this chapter, right? Moles, if it's in the table and it's not the first thing, it's going to be a 1. Now let's start writing in our other things that we know. We have 8.99 times 10 to the 14th. On the bottom, we need to have 6.02 times 10 to the 23rd, because that's how many particles are in 1 mole. And then 1 mole contains, well, now is where we have to find the mass. So 1 mole contains 14 for nitrogen times 2 plus hydrogen, there's 4 of them, times 2, so there's 8 plus 8 plus sulfur is 32 plus oxygen is 16, and there's 4 of them, so I'm putting plus 16 times 4, and I get 132. In the calculator, so we go 132 times 8.99 E14 divide by 6.02 EE23 equals, and you say, hey, Mr. Arnold, you did that backwards. Hey, it doesn't matter what order you do these in. As long as they're on the top, they multiply, and on the bottom, you divide. And I get point. And it looks like I have 6 zeros here. 1, 2, 3, 4, 5, 6 zeros. And then 197. What is that? It is 1, 2, 3, 4, 5, 6, 7 places behind. So it's 1.97 times 10 to the negative 7th grams. That's right, grams of NH4 2SO4. You're like, well, that's such a small amount. And the reason it's such a small amount is because we're talking about just a small number of particles. Okay, let me get that out of the way. What in the heck? And this is what that looked like. All right, scrolling up. Percent composition by mass. So percent composition by mass is like the test score, right? So we have to find all of our individual things. Calcium is 40 plus Mn. Mn weighs 55. And there's 2 of them. Plus oxygen weighs 16, and there's 8 of them. All right, now I'm going to write some numbers down with this because it'll help in the long run. 55 times 2 equals 110. And 16 times 8 equals 128. So 40 plus 110 plus 128. I got 278. All right, that's the total, just like your test score. There's 278 questions, right? And now we're going to do how many of each. So for CA, I like to write it above it because it looks cool. So CA, we have 40 divided by 278, and we're going to take a percentage of that. I'm not going to put the times 100 on there because I already know to do that. 40 divided by 278 equals 0.144, which is 14.4%. This is why I wrote those out. Now I have 110 divided by 278, and this will give us our percentage of manganese. So Mn, so it's going to be 110 divided by 278 equals, and I'm getting 0.3956, so that ends up being 39.6%. And I'm going to write this next one down here, and this is going to be oxygen, everybody's old friend. And we have 120, I didn't write 128, 128 over 278, and that will be 128 divided by 278 equals 46.0. I'm going to call this 46%. Hey, if you did this right, they're all going to add up to 50. I'm sorry, they're all going to add up to 100. So if you want to check them, if they add up to 100, that might mean you're in a good roll. It also might mean you did your masses wrong. So, well, they should add up to 100 though. Okay, we're going to determine the empirical formula. Empirical formula, remember, we have a pattern to follow. We're going to go from percent to grams to moles. Then we're going to do a ratio. And then that ratio is going to be converted into the subscripts. Right? And let's put my duck face. All right, here we go. So we're going to start out 40 grams of C, change that to moles. There's 12 grams in 1 mole. 6.7 grams of H. There's that thing in the way again, right? And there's 1 gram in 1 mole of H. And then finally, 53.3 grams of oxygen, and there is 16 grams in 1 mole. All right, let me punch in the things I couldn't do in my head. Come on, calculator. There we go. So we're going to take 40 divided by 12, and this was 3.33 moles. And then we're going to take 53.3 divided by 16, and that was, oh my goodness, 3.33 moles of O, moles of C, and I can already see what we're going to do here. Pick the smallest one of those, right? It doesn't matter which of those two we're going to pick because they're the same, but pick the smallest number and divide them all by that smallest number. And I don't need a calculator to know that's a 1, and that's a 2, and that's a 1. Formula, C1H2O1. That is an empirical formula. That formula would not exist by itself. Well, 1, 2, 3, 4. Oh, yeah, it could exist by itself. Yeah, that is formaldehyde. Okay. Any questions with that? Second problem is going to be exactly that same type of thing, except this time at the end, we're going to find out how many times that unit repeats. So we're going to find that same formula, and we'll find the mass of that formula, and then we'll compare it to the molecular mass. I hope that made sense. Hey, I'm going to come up here in this corner. Maybe I'll be out of the way. Maybe I won't. We'll see. Oh, I'm disappeared again. There we go. All right. The gas sample has blah, 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 blah. Okay, so we have the same idea as before. Let's set it up just like we did before. So we have 39.10 grams of carbon, and we put 12 grams on the bottom, 1 mole on top. That is carbon. We have 7.67 grams of H. We put 1 gram, 2 lines. 1 gram on the bottom, 1 gram on the bottom, and 1 mole on top. And that's H, and we could do that one in our head, 7.67 grams of, or moles of H. Then we have oxygen, right? No, yes. So there's 26.11 grams of O2. That's going to be 16 grams on the bottom, 1 mole on top, and that's oxygen. And then we have phosphorus. Oh my goodness, this is a big one. We have 16.82 grams of phosphorus, and phosphorus is 31, I believe. Yep. 31 grams on the bottom and 1 mole on top, and that's P. And I'm just going to write right through this thing. And now we have fluorine, and fluorine has 10.3 grams on top, 1 mole of fluorine, and then the mass of that was 19, right? Yep, 19. All right, I have a little bit of math to do. Give me a few seconds. I can do it faster if I don't talk about it. I need you kids here to tell me when I mess up. That might be our winner right there. We have a tie. Okay, so our smallest number of this group, of course, is the 0.54. We have 2 of them. We know that equals 1. Okay, that's a good sign. All right, oops. And so we're going to divide all these by that. So 1.6 divided by 0.54 equals, I got 3. 7.67 divided by 0.54 equals 14. Let's hope this works all the way through. 3.26 divided by 0.5. Try it one more time. 3.26 divided by 0.54 equals 6. Okay, so these were divided by 0.54. I didn't write it down. I should have. All right, there's my numbers I have. So I end up with C6, H14, oxygen is 3, that was phosphorus is 1, and F is 1. I do not know exactly what this is. All right, let's add up these weights of this thing. Okay, so we're going to find the total weights. I'm in the way here. Move over there, Mr. Arnold. There you go. Now we're going to find the total weights. So this is 12 times 6 plus, there's another way to do this too, but we'll just do it this way. 12 times 6 plus 14 plus 16 times 3 plus 31 plus 19. And that'll be the weight of that empirical formula, because that's the simplest formula. So 12 times 6 plus 14 plus 16 times 3 plus 31 plus 19 equals 184. That's what I was thinking. And you look at that right there, you say 184. Well, what does that mean? Well, the molar mass is 184. So 184 divided by 184 equals 1. You would multiply these numbers all by 1, which doesn't change them at all. So if this were a different way, so that's what the formula is going to be, the same in that case, but let's just play fun here. Let's say that it said this formula up here was 368 instead of 184. I just doubled it. And so you'd take 368 divided by 184, and that equals 2. And what that means is you'd have to multiply 2 by each of those numbers. So then the formula would be C12, H28, O6, P2, F2. All right? Now, I just made that up there just to show you because I didn't want to leave you with something that's exactly the same and just a weird thing that happened. If it's exactly the same number, you don't have to do anything. It's already simple. It's already the molecular formula. If it's a multiple of that mass, you'd have to add it up and compare to what they gave you. If that happens, then you multiply the number you get, the ratio, times all the subscripts. All right? Then I have a thing that says special conversion mystery problem. I can't talk about that because it's a mystery. Hey, that's all I have. Hopefully you understand how to do this. If you do not understand how to do this, remember I have a Zoom room that you can come into and I can help you out at any time during the school hours. Don't do it at midnight. I'm not going to answer after 3. Okay? So good luck with this thing. I hope it helps. If there's something I said that doesn't make sense, you know what? Ask. We can figure this stuff out. Nothing in this chapter is all that difficult, but it does take a little practice. And I know that almost took 30 minutes to do that whole paper. I expect the test to do the same amount of time with less than a half hour. Okay. Hey, have a great weekend and catch up on your work. It's the best way, the easiest way to do good on the test is to know how to do it before you take the test. Oh, that's pretty obvious. That's right. Okay, I'm out of here.